Hi, Dr. Archie here, and today I'd like to tell you a little bit about the gradient. First thing I want to do is remind you about some notation. So remember, if you have a multivariable function, say in two variables, f of x comma y, or three variables, f of x, y, z, or more, you'd do something similar. But two and three variables are the most common things you'll come across. So anyway, f sub x, or possibly curly df dx, either one is notation for the partial derivative of f in the x direction, or sometimes people say partial derivative of f with respect to x. And that means you hold the other variables constant and take the derivative as if x is the only variable. And then similarly, we have this partial derivative with respect to y, or the partial derivative with respect to z. These partial derivatives are the ingredients for the gradient. Okay, so what's the gradient? Technically, so first of all, this upside down triangle is the symbol for the gradient. And the gradient is a list of the first partial derivatives, fx comma fy. Now, if you're being really formal, it's technically a vector, which is a list which you've sort of assigned some extra meaning to. But I don't really want to get into vectors too much. I just want you to think of the gradient as a list of the partial derivatives in alphabetical order. Okay, so in the three variable case, you've got three of them, fx, fy, and fz. So let's have an example. So my function is 1 minus y squared. So first I want to take the derivative with respect to x, which means I pretend that y is a constant for a minute. Okay, so y is a constant, and I take the derivative of this, pretending the variable is x. Well, look, 1 is a constant. Y squared is a constant temporarily, so the derivative is actually 0. All right, what's next? All right, now partial derivative in the y direction. Okay, so 1, still a constant, so its derivative is 0. But now y is my variable, so what's the derivative of y squared? Got that minus sign there. And the derivative is 2y, decrease the power, the first. Okay, so once you've figured out what the partial derivatives are, if you want to write down the gradient, all you have to do is write down, okay, angle brackets, 0, comma, minus 2y. All right. Now, this is a formula right here, this line that I just finished writing, that gives you the gradient at any point, x comma y. Sometimes you need to know what's the gradient at a specific point. So in that case, I'll use notation like this. This says compute the gradient and then plug in 1 for x and -2 for y. All right, so it's still going to be a vector or list thing. Okay, so I plug in 1 for every x. There are none, but whatever. And I plug in -2 every place there's a y. Okay, so I got the -2 that was there already, and then I plug in another -2. Okay, so wait, let me do a little arithmetic here. So what have I got? I've got 0, comma, 4. All right, so that's my gradient. Now, gradient does have a really important geometric meaning, namely it, quote, points in the direction of the steepest descent. So we just were working on what's the gradient at gradient of f at 1, comma, minus 2, and we figured out that it was 0, comma 4. Okay, so that means if I go to the point, this is the x over here, this is the y, where x is 1, about here, and y is negative 2, about here, okay, that's here, and then I go up to my graph, right here, and then if I look 0 to the x direction, so not at all in the x direction, just purely in the y direction, well, that's what I have here, this arrow, then that line's not helpful, let me erase that. Okay, then that's, if I was standing right on this spot on the hillside, that would tell me the steepest upward climb. And you can see it's going straight up without changing y. Because if I angle off even a little bit in the x direction, right, that kind of makes it a little less steep. And then this picture over here on the right hand side, it's the same picture, I just rotated it so you'd have a better view of this arrow. So now this is the y side and this over here is the x side. So you can see it's just going kind of straight through in the y direction.